Hello, this is Dr. Oz. In this video, I would like to talk about decision analysis with probabilities. In previous videos, we talked about decision analysis without probabilities. Now I would like to talk about with probabilities. And I will cover expected value approach, risk analysis, and sensitivity analysis. Let's get started. So expected value is nothing more than multiplying the probabilities with their corresponding expected returns, payoffs, payoff times probability. When I add them up, that will give me the expected value. So if you remember our decision tree, it was looking something like this. I had one decision node, and I had three decision alternatives. Decision alternative 1 was going with small, 2 is medium, and decision alternative 3 was going large condos. And each of these had two possible state of natures or chance nodes. So node 2, node 3, node number 4. And if the demand is strong, I would end up with $8 million here. If the demand is weak, I would end up 7 million with small condos. If demand is strong and I choose medium, let's label them too, small, medium, and large decisions. And here state of nature 1 is strong demand. State of nature 2 is weak demand. All right, S1, S2. Strong demand, medium condos, I would make $14 million. Weak demand, medium condos, I would make $5 million. Strong demand, large condos, I would make the most money, 20 million. However, if I go with large and if I have weak demands, I would lose $9 million. So based on these values, I can calculate my expected value. So how would I do that? So imagine that these probabilities are given to me as well. So the probability here, let's say, is probability of S1, strong demand, is 80%. And probability of weak demand is S2, 20%. So based on these numbers, I can calculate the expected value for each node. So basically, I have, again, decision to make. And I have three possible decisions defined. And here I would get 80% chance that I will be paid $8 million. However, with 20% chance, I would be paid $7 million, which is, you will get here, if you multiply these numbers, 6.4, 1.4 more, $7.8 million. Not too bad. Let's do medium. 0.8 times $14 million, 0.2 times $5 million. This would give you 11.2 plus 1, which is $12.2 million. It's better than small condos. If I build large condos, I would get with 80% chance, strong demand, $20 million. With 20% chance, I would get negative $9 million. So the answer here is going to be 16 minus 1.8, which is $14.2 million. So as you see, the best alternative is choosing the large condo project because it gives you the highest amount of expected profit. However, this itself is not enough because we need to consider the risk analysis, and decision makers have different risk profiles. So let me just show you the risk profile for the large complex decision that we just thought is the best in terms of expected value. So here is the risk profile. On my y-axis, I have my probabilities. On my x-axis, I have my profits in millions of dollars. So if I get strong demand, basically I will be paid with 80% chance, with 80% chance $20 million. However, if I am not right, I will get with 20% chance that will be negative $9 million. So as you see here, there is a quite bit of deviation between negative 9 to 20 million. So someone may say, hey, this is the best expected value, but I don't want to take that much risk. I would rather take medium, which is at least I'm not going to lose money. I will at least get 7 million worst case. All right. So that's important to understand the risk profile. Another thing I would like to cover in this video is sensitivity analysis. When you conduct this kind of research, basically when you do recommendations, you make all these things based on subjective assessments. You make so many assumptions to come up with the payoffs and also assessing the probabilities. That's why sensitivity analysis is very important to understand. If I change any inputs, how would that impact my overall payoff? For example, if my probability of strong demand is 0.2, 20% instead of 80, and weak demand is 80% instead of 20, let's see what would happen to expected value of decision one. Then I would have 0.2 instead of 0.8 times 8 plus 0.8 times weak demand 7, which would give me $7.2 million. If I do the same calculations for EV, expected value for D2 and expected value for D3, I would get here $6.8 million. And here I would get negative $3.2 million. And as you see now, this is the large condos project is not the best. Actually, it's the worst now. The best project is small because the probabilities change. So it looks like the probabilities are very important on this decision-making process. That's it for this video. Until next video, enjoy business analytics.